Hi, I'm Karthik Rannan. I'm the president of the Wall Street Club of BITS Pilani Hyderabad campus. Yes, so the collaboration with XLR was an excellent one. We conducted a Power BI workshop with Advanced Excel over a span of 3 days. The workshop was almost 12 hours long in total. Mr. Karthik, who was an amazing trainer, helped the students understand the concepts deeply. I am sure that the students will be able to apply these concepts in their careers as well as their daily lives while they try to navigate the world of finance. I am happy that we will be able to close this workshop successfully on a very good note.
Hi, I am Raghunendra Singh and I am the Technical Director of the Wall Street Club at BITS Pilani Hyderabad campus. It was a great amazing conducting this workshop with XLR. The trainer, Mr. Karthik, was an excellent person where he explained in very detailed manner on how to give great insights using very complex data sets, which was very helpful for the people who are interested in the field of finance, business or analytics in general. Thank you.
I attended a workshop conducted by CSA and ACM in collaboration with XLR. So it was a machine learning workshop. We learned a lot from the course and it was a great experience attending the workshop.
The trainer was very helpful. He had a hands-on approach with his teaching and it was fabulous.
This was a great experience for me. So I would absolutely love it if XLR and its team would come again to our campus and conduct more events like this.
The journey was great. Initially, I thought that I was not proficient enough in Excel, but later I came to know there was no prerequisites for it, and then I applied for it, and it was a great course, and it started from basics and took me to a great extent.
Good evening, myself Kavya Ganatra. I am from Computer Science Association. I was the POC for this ML workshop conducted by CSA and ACM in collaboration with XLR. The experience of the workshop was really nice. The feedback from all the students was positive. They understood the concept. The workshop was also practical based with some questions. The experience with XLR was very smooth. They helped us in conducting the workshop smoothly right from the booking of the vendor and deciding the course till the distribution of certificates. In overall, this workshop was a success during our Technical Fest Atmos, and I thank XLR for being a part of it. Thank you.
Yeah, hello everyone. My name is Tasneem. I'm the senior manager at 98 percentile in the HR department. And today we did a wonderful drive with XLR. It was amazing right from the very beginning, from the very first day when I got in touch with them till today. I think it was an extremely smooth journey with them. There were multiple follow-ups done by the representatives in order to check that we would be, what time we would be coming, how many people would be coming, what vehicle we would get. To that extent, they were so precise in giving all the information to us. It was extremely great to get associated with them and have a drive at XLR campus. So we are very, very happy that we got a chance to do this. Now, coming to the students, what XLR had, I think they were extremely enthusiastic. They were well prepared. They were aware of what they are coming for. I think there was some back-end preparation which they did that was commendable. They also were very confident and they were open to any kind of thing we were asking them to do. That was I think the best part. Now, I really hope we have a very, very fruitful association with each one of them and XLR in future. We are really looking forward to have many more drives like this.
Hi everyone, my name is Prachi Sharma and I'm the Senior Project Manager for IT Department at 98th Percentile. So today we were here for this IT Bootcamp, right, this technical drive and at XLR. So it was a great experience and I would feel that the students, they are the freshers, right, but it doesn't seem like that. So if I talk about their technical and cognitive ability, they all seems pretty good in that and that's what I felt. And I guess they have been taught pretty well at XLR, so that's how they have performed good in their aptitude and the technical tests. So I wish them all the best and it was a very great experience over here.
Hi, this is Patan, Technology Consulting Manager from 98th Percentile. We visited XLR for the campus placement drive and it went very well today. Miss Ambika, Miss Pragati, everyone received us greatly here and we had a lot of enjoyable time here. The students even had great experience with us. They were interactive, they had good aptitude and all the technological skills they showed. I think they were all well and we really appreciate their time that they spared to us and I think we will be doing a great job. We are expecting a lot of people to be hired from them. Let's see. It was a great experience altogether.
Thank you.
Thank you so much.
From entering into the cyber tower to exiting out of this tower, the XLR team has been received me with such a care and pleasure.
I am the part of this XLR since 4 months. From the third month itself, they have conducted the placement sessions from the third month itself, and this is the fourth month, and this is the 98th percentile is one of the placement drive I have attended so far, and attending to this drive is such a good experience for me. All the HRs and the team made us feel very comfortable and confident.
XLR helped me a lot, and I experienced a lot of things today. So I'm really hope to be I placed in that company. I'm confident about that. Thank you.
Good evening, everyone. So I hope Aishwarya, you can start the session.
Okay, thank you.
Yeah, thank you.
Hi everyone, good evening. Is my screen visible to all? Yes, good evening. Okay, so welcome back to the class. In the last sessions, we had understood about the brute force attacks. We have understood about the verb suit, and using the verb suit, we have tried working on a lab, right? So in today's session, what exactly we will be learning is we will try to understand about the asymmetric encryption, okay? Using the public and private keys, how to encrypt the data, how to create a self-certified self-signing self-certificate, how to create it. So those things we'll try to understand in this workshop. Okay. So before that, what is encryption? Encryption is nothing but when you try to secure the data and you want to convert a plain text to a ciphertext, we would be using encryption technique, right? So there are two different ways of encryptions are being done. One is symmetric and symmetric encryption. The other one is asymmetric encryption. Asymmetric encryption is also known as public key encryptions. Okay, it is also known as public key cryptography, you can tell, or public key encryption. So, which is uses two related keys. That is, it is going to use the two key pair, we can tell. In symmetric, we were using only one key for encryption also, for decryption also. Okay, but here we would be dealing with two different keys. That is, we will be discussing about the public key, which is used to encrypt the data, and the private key to decrypt the data. Okay, so data is related to textual data is treated as a huge number, which is raised to the power of second huge number and divided by the third huge number to produce a reminder. So this and all we'll try to see in the practical. Okay, so the big questions with symmetric encryption is how do you transfer the key to the second party. In course of transmissions of key to second party, someone might access the key and he will be able to decrypt it. Okay, so if you're using the same key for encrypting also and decrypting also, there might be a chances to get an attacker can get into it and use the key because you're using same key to encrypt and decrypt. So to avoid those problems, we would be using asymmetric encryption, where you would not be using a single key, rather you would be using the key pair. So key pairs, or you can tell you would be using the two keys. So let us try to understand this in a simple diagram. Here you go. Okay, so we have a Alice and we have a Bob. So Alice need to send some data to Bob, or the better way, I will try to draw one diagram, simple diagram. Symmetric encryption. So in our symmetric encryption, we have Matching this is Alice. Okay. And similarly, we have Bob. So Alice need to send some data to Bob. Okay. So to make the communication secure, more strong, so he is using a asymmetric encryption. So asymmetric encryption means Alice is going to have public key and a private key. So let me show you what is that. So Alice is going to deal with public and private key. Similarly, each one of us would be having a public and a private key. That means whenever you try to create a website, okay, so if you take an example of the Google page, okay, so google.com, I'm going to google.com/about page or something. To know this website is secure or not, I have an option over here, okay, that is connection secure. So here it is, you would get a pop-up, okay, if connection is secure or not secure. To make the connection secure, there are set of protocols are being used. We would be using TLS protocols, we would be using uh, SSL protocols, where an HTTP CAN request would be done. So let us try to understand that one by one. Okay. To make your web application secure, we would be using some sort of protocols. And here, if I just go ahead and select one connection is secure, okay, and go ahead with the certificate is valid. Okay. Certificate is valid. And if you see, every website would be having a public key. Public key is nothing but anybody on the internet would be able to see your public key. I'm talking about here currently an web applications one. Okay. So anybody on the internet would be able to see your public key. Okay. So private key is the one which you are going to generate. Using this public key, I'm going to generate a private key of my own. So Alice is going to deal with one public key. Public key, I'll just possible. I'll try to change the color and see. No. Okay. So one is public and the other one is private key. This way I'll try to mark up. This is going to be a public key. Anybody on the internet will be able to see the key. And similarly, Alice is also going to have a private key. Using this public key, I would be generating a private key and try to use that. Private key will not, everybody would not be able to see a private key. It is also known as a secret key. Okay, only you will be knowing what is a key. Until and unless you don't share it, anybody, none of them would be able to get to know what is your private key. Okay, and now if you see here, Alice have to send a document to Bob. Alice need to send some document to Bob. So make a document or a file over here. Okay. This is the document need to be sent. So have to send this document from Alice to Bob you're trying to send. So what Alice would be doing, he would be using his public key and encrypt the data. He would be using his public key and encrypt the data. When you encrypt the data, what happens? The plain text is going to be converted into ciphertext, right? Ciphertext, not readable format. This ciphertext document is sent to Bob. So sorry. So yeah, Alice would be using his public key and would be encrypting the data. Well, let us have a look at this slide. Okay. To send encrypted message between Alice and Bob, we need two pairs of key. One is Bob's public key and a private key, and similarly Alice public key and a private. So public key are made available on the internet, but data would be decrypted only using the private keys. So key says that Alice wants to send message to Bob. To do that, Alice gets hold of Bob's public key. Sorry, I told wrong. Alice would not be using his public key, rather he would be using Bob's public key. So as we all know, the public key would be accessible on the internet. So everybody are able to understand. Is it confusing? Please let me know. Everybody are in the track. So we are discussing about this encryption, asymmetric encryption, to make a connections, to make a HTTP request, HTTPS request secure, or to make any sort of connection secure. We are going to uh, implement asymmetric encryptions. Okay, so that would be done with the help of a key pairs. We have a public and a private key. Now understood, everybody? Let me know if you want me to repeat any concept, and will be active enough in the classroom so that it will be interactive. Okay, fine. Now, Alice want to send some message to Bob. Okay, the Bob, Alice, what he would be doing is he would be taking a public key of Bob's and from the internet and encrypts it. He would be encrypting it. And Bob would be receiving a file, right? Bob's on receiving decrypts it using its own private key. What he will do? He will receive the decrypt data, encrypt data. That data he would be decrypting it using its own private key. Now, if Bob wants to send a message back to Alice, then he needs to encrypt the data using Alice's public key. Alice on receiving decrypts it using its private key. This way, what happens is it would be difficult to break or decrypt the data easily, right? Because I would not be knowing your PIN ID, or I would not be knowing your method, whatever the method you're trying to secure the data, right? If you're using any online material or something, it would be easy for us to crack it. But if you're using your own method, then it is going to be difficult to crack the password, just making it easier. Okay, same thing over here. So public key, private key. Public key on the internet, you can open any website, you will be able to get access to the private key. Okay. And one more thing is, like, to make sure this website, the connection is secure and then, right? Here the connection is secure. But to know, there is also something known as certificate. Okay. There is also certificate. Now, you have done your graduations, you have done your degrees, and you have taken, you got a good marks. And how do you prove that yes, you have studied in this college and you have been graduated? So what is the proof you're going to show to others? This is a simple basic thing, na? Like, if you wanted to tell to your families or somebody, okay, that yes, you have completed so and so degree, what is your proof? Certificate showing certificates and skill. Yes, right? We would be needing now, if you want to apply for a company or if you want to apply for internships, everything, they would be asking for your certificates, right? Whether they would be asking for your marks cards. Marks cards have your the what is a university and the board which board you're writing up the exam and so on, right? It need a graduation certificate so that it's just an identity or just a proof. It's not an identity, it's just a proof. Yes, you have done something like this. You have completed a degree, right? It's same thing with me also. If I'm just telling I have so many years experience, I would have some proof to show it. So, right, the proof is very important. Same here. Whenever you're making any website secure, there would be a certificate is going to be generated. Okay, we would be using different protocols to make it secure, but here this is a certificate. This is currently not in the plain text. This is the hash value. Okay, nobody would be, as I told, hash value cannot be converted back to a plain text. That is why hash value is just put on the internet that everybody can read it. Using this hash value, nobody can do anything. Okay, So it is one dimension. The plain text can be converted to a hash value, where a hash value cannot be converted back to a plain text. Why do we use? For the integrity purpose we use it. Okay, and let us try to understand about the details about the certificate. So we have a CA certificate, we can tell. Okay, so CA certificate is a certified authority, people would be telling it. So certified authority is, for example, what happens is a browser want to like you are sending some request on your browser to your server. Okay, so browser want to establish a secure communication with your web server, makes a request. So it would be sending a request to your server, and what happens, the web server would be sending back a certified along with that. So making again a diagram so that it will be easy for you all to understand it. I have a browser, okay, I have a server. So to have a communication happening between the client and the server, I would be sending some request. Okay. I need to access this data or something. Okay. A website name I'm going to give. I would be sending it on the server. What the server would be doing? It would be sending back a certification. It would respond. Along with that, it also going to send back the certificate along with agreed cipher suits, which is an algorithm to use for key exchange. Symmetric encryption is being used. So what I'm trying to tell is to make sure this data which I am trying to send, okay, it is a secure connection. Okay, this is a legal website, or this data or whatever I am trying to the server. Okay, whatever I am trying to share is a legal website. So to make that legal website only, we would be using a certificate. We would be using a generating a TLS certificate, you can tell, or not TLS is a there are different ways. We have a digital certificates. Okay, digital certificate. You would be self-signing certificate. Self-signing certificate is you yourself would be signing it by uh, with the help of your website. You would be signing, and then you have a CA certificate. CA certificate is nothing but the certified authority people would cross-verify what is your public key, what is your private key, is this website is secure, everything. Those CA authority would be signing it and they would be sending back. So when they sign it and send back, you would be able to see with the details. What are the details it is going to include is, it is going to include version number, okay, what is the version number, serial numbers, okay, certificate, signature algorithm, who signed it, with what type of algorithm they have used. They've used RSA encryption. So RSA would be lying under the asymmetric encryption, and they're using a hashing value of SHA-256. SHA-256 is a hashing method, hashing algorithm. An issuer, who issued it. Okay, so Google Trust Services issued this. They are the organization. Okay, what is a country, and the word numbers and so on you will be getting. The validity period. These are the certifications which is going to have. So same way, in if we discuss about our certifications, the graduation, we have a name, we have a last name, we have a degree, like what is this certificate is all about, when it has been issued, okay, and what is the percentage you are taking. We have a detailed uh, data, right, in the certificate. So that is a proof. Same way here also we would be having the proof with all the data being provided over here. We have a public key being provided. Okay, what is the key algorithm you're using, and then what is the extension, who is the CS certified authority key ID, okay, certified authority alternative name, about.google is a website I'm using, what type of signature using, everything is being provided. So we'll see how can we do it by our own, how to self-sign certificate we can create, and how do we use the asymmetric encryption. We'll try to understand this using the practical. Okay, shall we move forward? Okay, great. So again, we would move back to the slide. TLS, this is what we were discussing. TLS is a layered protocol that runs on the top of the reliable transport protocol. For UDP, we have DTLS. So TLS is a protocol which help you to provide the authentication, confidentiality, data integrity protection between two communication applications. It's TLS protocol. And then we have a server. Server has a key pair consisting of a key and a public pair. So these things, when we look into the practical, I'll just make you understand. See how we will how will key be exchanged? The server might dedicate to a RSA key exchange, and then the data would be encrypted. Many other things are there. So yeah. Now let us see how to encrypt and decrypt the data using the methods. So the first thing, what am I going to do it? I would generate my private key. Okay, using the private key, I am going to extract my public key. For that, first, what I'll do, I'll try to create a file. Okay, well, I'll create one file. We were in the last class, last class we had discussed how to we create. I'll use an echo command. Echo command. In my B, I would try to add up a content called the recorded classes. You need to check with the team related to it. Okay, kindly check with the team. Echo, and then I would just add up a data, might be happy hacking. Happy hacking is a content. I'm using an echo command and trying to add a content called happy hacking. And then I would go ahead and try to store. I'm going to create a file. Okay, might be data.key is a file name I'm going to create and give an enter option. Okay. So I repeat again, we are using an echo command which help you in adding up the data, and I am storing that data to a file called data.key. Let me try to view the data.key with the help of a cat command, data.key, and give an enter option. So you get a normal plain text as happy hacking. It's not only that you can just add one line of content. As I told you, you can also add up images, and we can also do an encryption and decryption to it. Okay. So happy hacking is done. And then what else we would do is, let us try to generate a private key. Okay. So there are different types of algorithms are being used in the for symmetric and asymmetric encryptions. Yes. So if you see here, symmetric encryption and public key encryption and digital signature. So if you want to do a digital signature, I would be using an RSA algorithm, which can be also used for asymmetric encryptions. Okay. So currently I'm using an algorithm called RSA algorithm, which is used for asymmetric encryptions. Here, I'm going to use OpenSSL, which is a command line which help you in protecting up your data, which help you in performing the cryptography. Okay, so I'll use an OpenSSL command. Then I'm going to generate a RSA using an algorithm. I'm going to generate the key. Okay, what is a key? Private key. First, I need to generate a private key. Using the private, I'm going to extract the public key. So have a look over here. So generate RSA. So GN is generate RSA. Okay, and whatever the data you're trying to generate, whatever the key you're trying to generate, where exactly you're trying to store that, I would be storing up the output, okay, O out to a file called data.key. Okay, might be I would just go ahead and try to store to a file called data.key or data.key1. Okay, and with what is the bit? What is it? Bit. So 2048 I would give. I'll give 2048 as a bit. So you have 168 bit, you have different bytes, right? So I'll give a go ahead and RSA value, that is a public key, is generated. How do I know whether the public key is generated or not? So let me try to view them. I mean, to verify them whether the data is generated or not. So I'm going to use OpenSSL back again. OpenSSL. Now I'm not going to use a generate RSA. I'm just going to use only the RSA value. Okay, I'm going to display the text. Display the text. And where is the input coming from? The input is from the data called data-data.key1. Data.key1 has a private key. So I should have given a private key. Okay, no. And then I'm not going to give any output to it. I'm not going to generate any output, so I'm going to give no out and give an enter option. See here, this is the private key. This is a private exponent, and public you have, but public is not very much visible right now, right? You also have a public, but it's not very much visible. So let us try to extract from this. And here, if you have a look, this is the private key I was talking about. Private key, it has from prime to exponent 1, exponent 2, coefficient. These are the keys I was talking about. Okay, everybody are getting? I hope you are doing along with me. If you're not doing, you can go ahead and try to search for asymmetric encryption in online. Okay, you can search for asymmetric encryption online tool. You'll get some online tool. You can have you can have a look into it. Okay, now we will go ahead and try to extract the private key using my, extract the public key using my private key. So same thing, I'll go ahead with the OpenSSL command. OpenSSL SSL command where I am going to generate. Okay, I'm trying to extract. Generation is only once is done. So now I'm going to extract the file, that is extracting of the public key, and along with the public key, I would also create one self-signing request. Self-signing request is being done by your website itself, not by a CA authority, and not by the certified authority person. So I'll use a RAC, and then where is the input coming from? The input is from a key called data1.key. Why am I using data1.key? Because this file contains a private key. Okay, so using this input, I am trying to generate my public key. So to generate a public key, I would use pub out. Pub is the public key. I'm going to create an output of it. Okay, pub out is nothing but you're going to generate a public key, and I would be storing that public key, that output file. I'm going to store it inside a file called might be data2.key. Data2.key is a file which I'm going to store it. Okay, and give an enter option. Now define the URL private key from data1. I give data1. Okay, data.key1, not data1. So it was something like data.key1 and similarly data.key2. Key2 and give a enter. So writing RSA key. So if you want to verify that the file, what is the data that the data.key2 is having. So I'll use a cat command also directly. Cat and data.key2 enter. See, this is your public key. This is going to be your public key. Okay. See here, begins with the public key and ends with the public key. This is the public key. This is already present when you create your private key. For this, you need to extract. Now, using this public and a private key, okay, using my private key, what I'll do, I'll try to do a self-signing certificate. That is the issue date, everything you were seeing, right? The same thing we'll try to do it on our own. For that, again, I will go ahead and use an OpenSSL command. Okay, and now here I would be requesting for the certificate. Now I'm not going to generate anything, I'm just going to request for a certificate using the request command. Along with that, req, okay, I'm going to generate a new key. I'm going to generate a new value, so new key hyphen key, and then using what? Using the key called data1 dot key. Using my private key, I'm trying to generate a certificate. Okay, and I would be storing up the value inside the certificate.csr. Any file name is fine. CSR and give an enter option. I'm loading a private key in this. Again, I'm doing the same mistake. It's data dot key one, not data one dot key. See here, what are we doing is we are trying to generate a new key. Okay, you are about to be asked to enter the information that will be incorporated into your certificate request. So basically, what are we doing? We are trying to request for this certificate. Okay, and a new key you're trying to generate. The file name is certificate.css. Output would be stored here. There you had having a country name, code name, everything, right? But here we would be manually doing it. That is what is called self-signing certificate. Self-signing certificate is nobody, like the CS authority people, the certifying authority, they would not be doing the self-signing certificate. Rather, we would be using our open website and we would be signing a certificate. That also is one way of self-signing certificate. Also is one way of proof. Okay, again I repeat, a self-signed certificate is a digital certificate. Okay, that is not being signed by a trusted certified authority, but instead is signed by the an organization that created it. Organization or a website, those who have created those uh, would be creating this self-signing certificate. While this certification can provide encryption and serve as a proof of identity. Okay, that is why we will be using a self-signing certification. So now let us try to go ahead. See a country code, I'll just give IN. You can use India also, it's fine. State, I'll give. And then locality name, something with AN, I'll give, just random. Organization unit, OU, I'll give. Okay, this way, organization unit name, CG something, enter, and common name, probably, and then email address xyz@gmail.com. I'm just randomly going to create it. But if you have, when you're trying to create a website or anything such, you would be creating on your own. Like I'll create a root as a password. Okay, an optional company name if you want to give, if I something. Now, this is the self-signing. I have myself, I've signed with the information, the details I have filled up with the detail, whatever that need to be printed. Now, let me try to review it. Let me try to view or verify the certification details. So, to verify that certification detail, again, I would use an OpenSSL. Okay, I would go ahead and try to request. Currently, I'm not going to request anything, so I'll give no out. Okay, I'm not going to produce any output page. Rather, I'm going to display the text. And where is the input coming from? The input is from the file called .csr. And now I would get an error. Okay, good. But I did not get an error. Fine. So I'm using a text. Okay, I'm trying to display the text and the certificate.csr. I thought I had given a wrong name. Okay, it was correct. Where the certificate request, and it has the data. See here, the version, the subject. Okay, see here, public key. Public key is being generated over here. You also have signature algorithm using a SHA value. and then you have a signature value, and along with that you have the country name, state name, local organization's name, and then additional data is being provided over there. The same like if you have a look into the Google.about page, we have seen a certification over here, right? Security certification is value. See, we have some common name, organization unit, right? Issue date, certificate, public key, some details you were getting, right? Serial numbers, okay? What type of public keys, hashing values, everything is being provided. Understood? This is how we would be doing using an algorithm. See what type of algorithm you're using. We are using an RSA encryption. All those details are being provided so that it would be used for self-signing certificate, which is also used for identity. Okay, not an identity. It's just a proof for your website. Okay, that it is secure and it is legal website. Understood? Hope it was not confusing to you all. It was like step-by-step procedure only we are trying to do it. Now let us try to encrypt this data using the asymmetric encryptions. Okay, till here we have just seen encryption like generating a public key, generating a private key, and generating the self-signing certificate. Now to generate to encrypt the file using the public key, how do we encrypt the files? Same thing, I would be using OpenSSL. Okay, I would be using RSAUTL. It's basically a symmetric algorithm, and where exactly I would try to encrypt the data. Encrypting the data, what data you're trying to encrypt, okay, and where exactly an input key is coming from. The input key, I'm using the public key. The public key is stored inside a file called data.key2. Am I right? Data.key2, and then I would also get like you want to have the public key inside where exactly you're trying to use this public key. Pub in the input is coming from a file called data.key. Okay, the first one which we have created, we are using a private public key, and we are trying to encrypt the values. Data.key, using my public key, I would be encrypting the data. That is what was being told in the theory, right? We have understood in the theory. So data.key, and then that file I would be, now this file I would be extracting it and storing it to an external file. So dot out, I would write encrypt dot, okay, encrypt dot dot txt file. Give an interruption. Repetition. Yeah. Just having an issue. PQUTL. So let me verify whether that file, the encrypt.txt file. Let me verify that file. What is the file? Encrypt.txt file. See here. This is the value of the encryption method. This is the file which is being encrypted, and this is how it is going to look like. Okay, what are we doing here? I would again repeat, don't get confused. We are using a file which was created in the starting, right? Or that is happy hacking. So until now, we have seen how to generate a public key, how to generate a private key, how to generate a self-signing certificate. Now, using the public key, how to encrypt the data we are seeing right now. So I would be using an OpenSSL, and then I would be using an algorithm, and I am trying to encrypt the file using the key called the public key. What is where which file you're trying to encrypt? That is, I'm using an input file, that is data.key, and that file I'm trying to not extracting, encrypting it and storing it to a file called encrypt.txt file. Okay. Now to extract the file, to decrypt the file, I need to use my private key to decrypt the file. So same thing over here, I would again go ahead and use OpenSSL. Okay, OpenSSL, and use the key algorithm. So P key UTL, and then here I would not use an encrypt, rather I would be using decrypt. I'm going to use a decrypt. Okay, which file you're trying to decrypt? I would be decrypting the file called. Can you tell me, if you have understood till here, you can tell me what is the file we are going to decrypt here? Can you tell me the file name? Look into it, look into the terminal properly and tell me what is the file we are going to decrypt right now. No idea? Data.key2, data file. Data.key2 is the file we would be using it to decrypt it. Okay. Now, which file I would use my private key to decrypt the file, but which file I want to decrypt it? Alice have sent some document to Bob. Okay. So Alice have used Bob public key and he is encrypted. Now Bob received the document. So he would be using his private key to decrypt the file. But what file he's going to decrypt? The file which was sent by Alice, right? That is the file he's going to decrypt using his private key. Same way, here we would be decrypting the file called encrypt.txt. Right? This is the file which I need to decrypt it using my private key. So that is important. Okay. So I am going to use my private key, that is data.key1 is going to handle with the private key. Okay. And where is the input coming from? The input is from the encrypt.txt file. And where exactly you are trying to store the output? The output is going to be stored inside a file called decrypt.txt file, and give an enter option. And if you want to look into the file, that is decrypt.txt file, I would use a cat command, and then I would use a decrypt.txt file. See here, happy hacking, you got the data back again. Now you understood the logic how a public and a private key is going to be used. Yes. So I hope now everybody got an idea how a secure transaction or secure communication can be done from one medium to another medium. Okay. So now we will try to go ahead and try to understand few things. That is coming to the threats and all. In the next class, we'll try to understand. But we'll try to have an overview on the application securities, network securities, and so on. So we have network security. In detail, we'll try to understand it. Network security refers to the protection of computer networks and the services from unauthorized access, misuse, modification, or destruction is happening, right? So in network security, like you can use in the network or information security, the SOC, okay, GRC, these and all will be coming under this network security and information securities. So what they would be doing is they would be monitoring whatever the activity, like the unauthorized activities happening, any vulnerabilities, any threat is happening, they would be monitoring, and based on that, they would be mitigating the data. So it involves the use of hardware and software technology. They would be using the tools to work on that, as well as the security policies and procedure. So GRC, okay, regular compliances, and in the risk assessment or the policies and all is there. What is policies? Procedure is nothing but rules and regulations that need to be done followed. Okay, so an organization is working for, an organization is there, they have multiple clients are being used. Okay, a client has some set of rules. Okay, they would have different types of frameworks are being used, different types of standards are being used to create these policies. Okay, so that means how a data need to be transferred, okay, how a data need to be stored, and how are you going to document it. Those are the standards are going to be used, set of rules and set of procedure that need to be followed. Social engineering attack, okay, I'll show you. I will explain you about that. Okay, I'll quickly complete this and take it. So it involves the hardware and software technology, as well as the security policies and procedure to secure the network infrastructure, application, and data. Next, we have mobile security. Mobile security, who is going to deal with like, yes, penetration testings would come under this. Mobile security, app securities, web application securities, these and all will be coming under the VAPT. Okay, mobile security, mobile devices is used to store and access sensitive data such as personal and financial information that are they and are therefore a prime target for attackers. So mobile security includes a combinations of hardware, software, and best practices to protect these devices and the data they contain. Any devices if you have, okay. Now the currently we have seen encryption techniques, so on, right? Those category, everything would be involving in the mobile security. So how to secure any applications? Okay, you can use AppSec. Okay, application security, they would tell how to protect your data, what types of protocols you need to use, and then you have a penetration testers who would be telling like who would be doing an attack on it and figuring out what is the vulnerability being used. Those things will be falling under this mobile security. Then we have a cloud security. Cloud security, those who work on the clouds. Cloud is like whatever the data are stored in the cloud, the data can be anyway. Okay, like we are using the Google, no, the Drive we are using, na? Google Drive, Google Photos. It's just a photos. When we delete, also we our data are being found. The reason it's stored in the cloud. So to maintain or to what is that, to keep the data secure, the cloud security are being used. Okay, the cloud security is not only with the informations about the pictures or something, there are various different data. An organization, everybody, they would be physically, they would not be storing up the data. Everything is being done virtually on the internet and on the cloud platform. So cloud security refers to the protection of data, applications, and infrastructure associated with the cloud computing services. So they are set of services which are being running. Okay, so to make sure in cloud securities, there are different types of roles being used. Like have security engineers who would be working, security architects who would be working on the cloud security. So cloud computing allow user to access and store data and application over the internet rather than on local hardware. And it's widely used by a business and individual to increase the efficiency, flexibility, and scalability of your organizations. Then we have application security. Security, the brute force attack, okay, those things and all would be the top 10. The web application security. In the next class, we will be discussing that. So, application security refers to the protection of your software application from external and internal threats to figuring out what is the vulnerabilities are being used. Again, I would tell it would be penetration testing, ethical hacking would be coming under the category of the application security. It involves implementing the measures. So here we are not monitoring. Along with monitoring, you are also going to tell what is the controls, okay, what impact would happen when this attack is going to happen, and how are you going to control this, okay? So I'm telling you, as elders, they used to advise us, right? They would give us advice and they would tell, okay, if you do this one, good thing is going to happen. If you do this one, bad thing is going to happen, right? I'm just telling you the experience. Same way over here also. In the application security, what happens is you would be figuring out the vulnerability. Okay, based on the vulnerability, what attack can happen, and then how are you going to control those? Can be done in the application security. It's just not only monitoring it. Along with monitoring it, you're going to mitigate. Along with mitigate, you're going to also provide the controls of okay, that is what an application security is all about. And then we have other like identity management and data security. Data security like protecting of the data. This can be done in various different roles. Okay, any security engineers would be working on this identity management in data security. This also would be using some ways of authentication, authorization, and the CIA triad would be used. Here, what happens is they would be using some standard IAM, you can tell, okay, they would be using some policies to protect your organization from the threats. And yeah, so the next class we will be understanding about the cyber threats, and before that, the social engineering, right? So social engineering attack is basically an attack, okay? What happens in the social engineering attack is, I have a slide, I can show. Hotline rescue management, okay. I don't have that slide. Okay, so I'll tell you. So social engineering attack is basically you are trying to an attack which tried to manipulate or steal the user's informations. So that can be done in various different ways. Okay, one of the best things, or not the best, is one of the attacks which is happening right now is the phishing attack. Phishing attack would be coming under the category of social engineering attack. Okay, it's more of tricking a user and trying to making a user to trust them and steal the informations, trying to steal the information. They can be like manipulating the attacks or whatever it is. So this phishing attacks, which I was talking is, you might come across with in Instagram, you see some ad. Okay. So that ad is, we get ads in Instagram sometimes, right? So that is about the free cybersecurity course or some courses ad you're getting. What do? You don't do a proper research. Proper research means whether this website, this ad is legal or not. What do? You get, you just go ahead and click on the button, whatever is provided. What happens when you click? It looks like legal. Okay, that ad looks like legal, but actually it is not legal. What happens directly? It would ask you for your information. Enter your name, enter your passwords, enter your email ID, enter your mobile phones, enter your personal details, whatever it would ask. Okay, it looks like legal. So what you do? You go ahead and try to provide an input. You try to provide your details, and they would trick you and collect your information. Okay, they would steal your information. This is what is social engineering attack is all about. In the next slide, I'll show you one example on the phishing attack, how it is happening. Not on the phishing attack, something related to it. I had told you all, like, we have a Portsweaker. Okay, Portsweaker is one of the website where you can work on the various different labs are being provided. So you can go ahead with that, and you can also get the social engineering attack over there also. And we would also see in the next class. Okay. Right. I'll stop sharing. If you have any doubts, please do let me know in the chat box. So we are here in the fourth class. So how are you feeling? So quickly, can you all provide some feedbacks? Are you all able to understand about the cybersecurities, what is happening in cybersecurities, and so on? Yes. So whatever we are studying, it's just a few things we are saying. They're very big things. There is vast, okay, many things we need to learn. But yeah, if you get interested, you can go ahead with specific domain and you can start reading about it, exploring about it, okay, getting certifications along with that. Fine. Okay then. So I think I would wind up for now. Thank you all.
Yeah, thank you, Aishwarya. So, students, thank you for joining. So, we'll meet on tomorrow. So, tomorrow is the last day for this session. Yeah, thank you. Good night.